Okay, welcome back to another video lecture from Math 1316, Plane Trigonometry. And in this video lecture, we are looking at the unit circle, section 3.3. Now, section 3.3 has some notes provided by the textbook, but it's not, in my personal opinion, the best way to teach the unit circle. The main thing that we're looking for here is how to fill out the unit circle in a way that is nice and easy to remember. So what we have in front of us is a blank unit circle. And we alluded to the unit circle a while back. And the function of the unit circle is that it is just a diagram, contains all of the nice, easy to remember measurements for various different common angles throughout the course. Let me get it over into quadrant one here. So the unit circle is based off of the trig ratios that we already know because of our time in section one. And the special right triangles that we dealt with were the 30, 60, 90 triangle and the 45, 45, 90 triangle. And then we have these quadrantal angles 0, 90 degrees, 180 degrees, 270, and 360. And what the unit circle enables us to do is to write these ordered pairs that you see listed along the outside of the circle here that give us the sine and cosine ratio. So we do need to remember one of the most fundamental identities in trigonometry, which is that the cosine squared of theta plus the sine squared of theta is equal to 1. And the identity, this Pythagorean identity, is just the parameterized version of this unit circle. So here I have the unit circle, and we remember that the cosine was related to the x coordinate and the sine was related to the y coordinate. So what that gives us is that these ordered pairs listed as x comma y are just the sine and cosine values for each of the common angles that we'll see throughout trig. Now, another thing that's worth noting here is that because this is a unit circle, well, a unit anything is just a single copy of that unit. And so a unit circle has a radius of 1. Okay, so to begin with, we can very easily write out the unit circle coordinates for the x-axis and the y-axis, knowing that the radius of our circle is 1. If this center point that's in kind of the bottom left of the screen is 0, 0, then a radius of 1 along the x-axis will take us to 1, comma, 0. A radius of 1 along the y-axis will take us to 0, comma, 1. I can then move to the left-hand side, and we can see that a radius of 1 along the negative x direction will take us to negative 1, comma 0, and a radius of 1 along the negative y direction will take us to 0, comma negative 1. Now, it's also worth noting that because the Pythagorean identity is the parameterization of the unit circle, then the old geometry equation for a circle, x squared, whoops, and it has zoomed way out. Sorry, guys. I'm trying to zoom in here with, oh, it's turning everything. I hate it when it does this. Okay, try this again. Let's just zoom in as far as I can. Okay. Still learning how this thing works. Okay, so x squared plus y squared is also equal to 1, and this is the equation of a circle with radius 1 centered at 0, 0 from geometry. So this should make a degree of sense to us. Now the other thing is, notice that this is just a version of the Pythagorean theorem, which is a squared plus b squared equal to c squared. It's just that our hypotenuse side will always be 1, so c squared is always just 1. And the ordered pairs that we come up with, if we plug them into Pythagoras's theorem, a squared plus b squared equals to c squared, these ordered pairs must square and sum to make 1. So what we want to do is figure out what all the degree measurements are based off of our special right triangles that we calculated earlier. Now, we always start from 0 degrees down at the bottom. And then remember that we had the 30, 60, 90 triangle and the 45, 45, 90 triangle as our like reference point for this. So 30 degrees is less than 60 and 45 degrees is also less than 60, and then 60 is less than 90 degrees. And of course we know that the uh, x and y axis form a 90-degree angle to each other, so we put 90 in this spot up here, and that's going to be kind of hard to see. Okay. So notice that each one of these small wedges here, and I can try to highlight it. Maybe I can, maybe I can't. Each one of these small 30-degree wedges is precisely 30 degrees. So every amount of space that I move, which is one of those wedges, will just be like adding 30 degrees. In other words, if I want to go around the outside of this circle, I can see it goes 30, then I move another wedge and it goes 60, I move another wedge, it goes 90, move another wedge, it goes 120, move another wedge, it goes 150, and then I move another wedge and we end up at the 180-degree marking, which is in a straight line to the 0-degree marking. Now I can continue going around the outside of this circle, but I'm just going to deal with the top semicircle because the bottom follows the same sort of pattern. You just add 30 every single time and so on. Now notice that these spokes in the middle of the 30-degree markings are just the arithmetic average between the two, or in other words, they're off by 15 degrees. So 120 plus 15 degrees is 100. It's freaking out again. 135. Okay. Now, next we can just recall what our calculated sine and cosine ratios were for each of these degree markings and write them in the ordered pair. Now, remember, we want the cosine to represent the x coordinate and we want the sine to represent the y coordinate. But there's a very nice trick for remembering how to do this that's pretty quick, and then that way we don't have to continue just memorizing a bunch of stuff and hoping that we can regurgitate it accurately. So the trick is we start from a spoke, which is 30 degrees off of the x-axis. So in this case, 30 is the obvious choice. We also start with the y component. And what we're going to do is just count up from 1 to 3, and then we'll count up again in the reverse direction from 1 to 3. So we put 1 in the 30-degree y coordinate, and then we count up in the next spoke, 2, and then we put a 3, and then we'll just reverse the direction and count up from 1 to 3 again. So we'll have 1, 2, 3. Now, it's also important to remember that on the unit circle, everything that is not a quadrantal angle will have a denominator of 2. So put all the 2's on. And then we take the square roots of all of the numerators if we can, and if we can't, then we just leave them as the expression square root of whatever that number is. So square root of 1 is 1, square root of 2 is just square root of 2, square root of 3 is just square root of 3, and then we notice, whoop, that does not like what I am doing there. I have not figured out why that is happening. Anyway, it's a square root of 2. It's just square root of 2, square root of 3, is just square root of 3. And then we notice that there are 4 square roots in the numerators for each of these um, sets of 3 ordered pairs. And another thing we can notice once we've filled out this first spot here is that the uh, other quadrants are just reflections of these things. So notice how we have a square root 3 over 2 comma 1 over 2 in the 30-degree marking. So the spoke over on the second quadrant, which is equal to 30 degrees off of the x-axis, has the same sine and cosine absolute value. So this is 1 over 2, and this is square root 3. Yeah, and I don't know why this is happening. It's really annoying. Square root 3 over 2. And from here, you can just copy over the other values. Square root 2 over 2 will go to 135. 1 over 2 comma square root 3 over 2 will be the 120 value. And then we can do the same thing for the bottom side. Now notice also that since we are on the negative side of the circle, or on the negative x side, all of these x values will have a negative out in front of them. The y values will still be positive because we're on the positive y side of the circle still. So we do have to know that the absolute values of these are all the same as they were in the first quadrant, but we have to apply positives and negatives based on the side of the circle that we're on. Now, the other thing that's worth noting about the unit circle is there's this blank in each of the spokes that is specifically for radian measures. And radian measures are really, really nice because they are very easy to write down on the unit circle. That's another advantage to having radian measures as opposed to degrees, is that it's basically just a matter of counting. So we have to remember a pattern, and the pattern is extremely easy. It is just 6, 4, 3, 2, 3, 4, 6. So it's like this palindrome number 6, 4, 3, 2, 3, 4, 6. And what this pattern gives us is the denominators of all of the radian measures in the spokes on the unit circle. So 30 degrees has a denominator of 6, 45 has a denominator of 4, 3, 2, 3, come over here, 4, 6. Okay, next we can remember that every single radian measure is in terms of pi. So we just put pi in the numerator of every single radian measure, and I'm doing my best here. And then to find what the other number, what the numerator number is for each of these, we just remember that once we've done this for quadrant 1, that's done. So now all we need to do is count how many wedges of the size equal to where that spoke is have we moved across the unit circle. So what I like to do is show this using pi over 2 because it's very, very easy. Notice that the pi over 2 spoke divides this semicircle into 2 equal parts. So when we count to pi over 2, that's one quarter circle, I guess. And then when we count to 180, that's 2 quarter circles, or in other words, 2 pi over 2. But 2 pi over 2 is just pi, so I'll just write down pi here for the radian mark. Okay, we can do the same thing with pi over 3. So if I count to pi over 3, notice it divides this semicircle into 3 even parts. So we have pi over 3. Then we count to the next pi over 3 marking. I'll move the cursor in front of that's right here. And that's 2 of those third circles, or I guess it's a sixth of the total circle. So that's 2 pi over 3. So that when I get to the 180 mark, it'll say 3 pi over 3, which is again just pi. I can do the same thing with fourths. So notice that pi over 4 divides the semicircle into 4 even parts. So we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi. Whoops, went back to a different video. Sorry. 4 pi over 4. Okay, so if we count those out, we know that we already have pi over 4. 1 pi over 4 is already filled in. 2 pi over 4 is just pi over 2, so we leave it alone. And then we have 3 pi over 4 right there. I'm going to back this up a little bit here. 3 pi over 4 right there. We can do the same thing with pi over 6. And notice that this is just 30-degree wedges. So we can count. There's 1, 2, 3, 4, 5 wedges before we get to where we have 6 pi over 6, which is just pi. And we can fill out all of the radian measures around the unit circle in that way. Okay, when all is said and done, we have a unit circle which looks like this. So notice that this is a completely filled out unit circle. And of course, anybody taking this particular course in class, we will fill this out several times. Basically, you do this once a day for about a week and a half until I'm sure that you know what this unit circle is. Now, this particular section, as I always try to signpost in class, 3.3 is one of the most important lessons in the entire course. So you need to make sure that you either understand what the tricks are in order to fill out the unit circle, or two, that you have looked this up on your own. You can Google it pretty easy. You just Google filled out unit circle and you'll see about 1,000 results for this. And you either have to have it memorized or you have to know what the tricks are in order to fill this thing out. Furthermore, you have to know that the x coordinates of those ordered pairs along the outsides are the cosine values, and that the y coordinates along the outside ordered pairs is the sine values. And if you understand that, then you understand 3.3.